Alright, today we're going to talk about parabolas, and you guys learned in previous math classes about general characteristics of a parabola. It has an axis of symmetry, a vertex, it hits the y-axis, sometimes it hits the x-axis. We did a lot of work on parabolas, quadratic equations. Do you guys remember what the equation looked, what a type of quadratic equation looked like? You guys remember the forms? There was vertex form, there was, right? That's a parabola. That's the parent function, right? Looks like this. What if it was y equals negative x squared?
It's upside down.
The upside down. Okay. Now, what you're going to learn, there's other characteristics of a parabola. Okay, and you're going to learn this today. You can also have parabolas that are on its side, like that, or you can have one that looks like this. What's the difference between what I just did? These branches are pointing to the think of positive side, these branches are pointing to the negative side. So, there's two different types of orientations of parabolas. If it is going up, like this, or down, it's going to be y equals x squared. If it's on its side, it's going to be x equals y squared. Now I'm going to show you how to do this a little differently. We're not going to do x-intercepts, y-intercepts. We're not going to do all that. We are going to define this a little different. What is a parabola? It's a set of points that are equidistant from a point called the focus. This focus point is always inside of the parabola. And this distance from your fixed point to a point on the parabola is the same distance from that point on the parabola to a point away from this line called the directrix. Okay. The directrix is an imaginary line. It's not part of the graph. So in other words, this is your parabola right here. This is the set of points. Whereas the distance from this fixed point to the point on the parabola is the same as this distance. Even though this does not really, it's not part of the graph, it's a line. A lot of times they'll make it broken, or you can make it solid. But this directrix is a line that is not part of the graph. So this is the graph. This is a line that does not touch the parabola. So the distance from any point on the parabola from the focus to the directrix is the same. And that's what it is. So now, I want you to understand do you guys have on your graph these drawn? Are these drawn on your worksheet? No?
No.
Okay, I want you to do this for me. So, if it is an x squared problem, you're going to remember 4py or negative 4py. If it's a negative 4py, it's going to be upside down. If it's a positive 4, it's going to be right side up. So if the x value is squared, it's a regular parabola. So think of it as like this. If you see something like this, it's x squared equals 4py. And if you see it upside down, it's x squared equals negative 4py. What is the p-value? P-value is the distance from the vertex to the fixed point. The fixed point is always inside of the parabola. So for example, if I gave you this parabola right here, and I said the fixed point is 0, 3. So the vertex is 0, 0. you would write x squared equals 4py, where p is the number of units from the vertex. So from here to here, it's 3 units. So you would insert a 3, p is 3. So in other words, x squared equals 4 times 3 times y, or x squared equals 12y. That would be the equation of this. Now, what is the directrix? If p is 3, you go 3 units away from the vertex, and you're going to draw a line that will not cross the parabola. So if I asked you what's the equation of this directrix, it's the line y equals -3. Okay, so what this means is, and I know my picture's not drawn to scale, but if you had a piece of graph paper, it would look a little bit better. The distance from here to here is the same as here to here. Any point that you pick, that's what your definition of. So any point you pick, this distance equals this distance. That's what makes your parabola. Now, what if my parabola was going upside down, like this? And I said p is -2, 0, -2. So this would be x squared equals -4py, because it's upside down. Where p is 2, you would put a 2 here, so your equation would be x squared equals -4 times 2y, or x squared equals -8y. Now, can you rewrite this equation? Absolutely. You could solve it for y and divide by -8. Now, what if your graph is on its side? What if you see the graph looking like this? Well, then the y value is going to be squared, and it's going to be 4px, like that. Instead of, so think of x squared is going up and down. If it's y squared, it's on its side. Now for this one, if the branches are pointing towards the positive side, it's a +4. Versus if it's pointing to the negative side, it would be a -4px. And again, your directrix is going to be, let's say I said your fixed point is 3, 0. 3 is going to be your p value. P is 3. You put a 3 here, and 4 times 3 is 12. Now, what if it were going the other way? And I had p is -3, 0. You would have y squared equals -4px, and p is 3. P is always a positive number. It's, think of the absolute value of how far is that number from 0? It's 3 units. So this equation would be y squared equals -12x. Okay, easy enough? Now, the directrix, if it's on its side like this, and I said p is -3, 0, that's your fixed point. That's your fixed point. Then your directrix would be 3, you go 3 the other way, the same number of units from your vertex to your fixed point. You're going to go that same number of units. So p, if p is 3, you're going to go p number of units this way and this way. So this would be your directrix. Your directrix is the line x equals 3. You get this? Okay, so let's do some examples. So by the way, make sure you have these drawn in here. So if it is a positive, if it's x squared, they're going to be up or down like this. If the 4, you always have a 4 in this problem, and that's going to help you figure out what p is. That's going to help you get your fixed point and your directrix. If it's on its side, the y value is going to be squared. With a +4, the branches are pointing to the positive side, and if it's a -4, the branches are pointing to the negative side. Okay. All that this second equation is it's solved for x. So if you solve this for x, you get y squared over 4p. So if you were to take this equation and divide by 4p, that's how you get this. X is equal to y squared times 1/4 p. Okay, so flip to the back side. Look at example 1. It says, what is an equation of the parabola with the vertex at the origin? So let's draw this. The vertex is at the origin. And the focus point, your fixed point, your C value, is 0, 2. That's your P. So from here to here is going to define P. So I know it has to look like this. There's no other way I can draw my parabola. The fixed point is always inside of the parabola. So is this going to be an x squared or a y squared problem? It's going to be an x squared. Is the 4 going to be a positive or a negative? Positive, because it's going up. So that's what I start with. That's my sort of my recipe. Now all they want to know is what P is. P is, how many units is it from the fixed point to the vertex? 2. So you're going to put a 2 right here for P. So x squared equals 4 times 2y, or x squared equals 8y. Now understand that this is good enough, but you could solve this equation for y. You could divide by 8. So in other words, 1/8 x squared is equal to y. That's another. These two are the same equation. One is solved for x squared and one is solved for y. Next one. This one, they give you the equation y equals negative 1/12 x squared. You have to figure out what, they want to know what the focus and the directrix is. So I need that P value. You're going to force a factorization of a 4 out of this. So the first thing I want to do is I want to get this thing to look like this. X squared equals 4py. I want to make it look like that. So the first thing I'm going to do is reverse this. Negative 1/12 x squared equals y. All I did was flip-flop this. Now I want x squared by itself. So how would I get rid of that, negative 1/12? If I multiply both sides by negative 12, I get x squared equals negative 12 times y. Now, I want to force a factorization of a negative 4 here. So if I pull out a negative 4, I will easily figure out that P value is 3. So in other words, I have a parabola that the vertex is at the origin, 0, 0, and my P value is 3 units. So my directrix is going to be this line, y equals 3. And my fixed point is going to be 3 units inside from the vertex, so 0, negative 3. So the two things they're asking you is what's the equation of the directrix? It'd be y equals 3. And what's your fixed point? 0, negative 3. You want this P, you want to figure out what this P value is. So you're going to force a factorization of a 4 or a negative 4. Does everyone understand that? You're going to pull out a 4 or a negative 4. Next one. So, this one they give you, what's the equation of the parabola, and it has a vertex at 0, 0. And if the focus is 0, negative 1.5, where is 0, negative 1.5? It's right here. So if this is your fixed point, this is how my graph's going to look. So what is P? How many units is the fixed point from the vertex? What's P? 1.5. So is this equation x squared equals 4py, or is it x squared equals negative 4? So let's start with that. Which one is it?
Negative 4.
It's this one. All you need to do now is plug P right here, and you're done. So x squared equals negative 4, P is 1.5, and you can leave it like this, or if you multiply these two, you get negative 6. And the other thing you could do is divide by negative 6, so y is equal to negative 1/6 x squared. So these are all different versions of the same answer. Next one. It says, what's the vertex, the focus, and the directrix of this parabola? They give you the equation y equals x squared over 4. Okay, first of all, I want x squared by itself. So if I multiply 4 times y, I get 4y equals x squared. So in other words, x squared is equal to 4y. You need to pull a 4 out of here. Well, that's easy. 4 times what gives you 4? 1. So that tells you your parabola is up like this. It's right side up. And your vertex is 0, 0. Your fixed point is going to be 1 unit from the vertex. So 0, 1 is your fixed point. And your directrix is going to be 1 unit away from your vertex. And it's not going to touch it, so it's got to be a horizontal line at y equals -1. So P is defined as 1 unit. 1 unit away from the vertex and 1 unit away the other way. You're going to go 1 unit away, 1 unit away. Okay? Next one. It says, what is the equation of the parabola with the vertex is at the origin and the directrix is 1.25? Okay, so what you want to do, this is the picture that they give you. So you know that your vertex is 0, 0, and your directrix is the line y, x equals 1.25. So how many units is the vertex away from that line? It's 1.25. So that's your p-value. Your p-value is 1.25. So if you plugged in 1.25, now why did I put a -4 here? Because if this is the directrix and that's the vertex is at the origin, these branches have to be pointing towards the negative side. So that's why, now if it were the other way around, then it would be a +4. If this were my directrix and my vertex was the origin, they would be going the other way. Then it would be a +4. But I know that P is 1.25 units away. All you're going to do is plug 1.25 here, and if you multiply, you get -5. So all you have to understand is that this is your equation, or you could rewrite it for x is equal to -1/5 y squared. Next one. Same problem, but this one, I need to get y squared by itself. So it says x is equal to 0.75, and if you want to change 0.75 to 3/4, okay, same thing. Now I like it when my equation is written like this, and I need to get y squared by itself. So how am I going to get rid of this 3/4? Multiply by 4/3. So y squared is equal to 4/3 x. Okay, now you need to force a factorization of a 4 out of here. So 4 times what is going to give you 4/3? 1/3. So that's your p-value. So this tells me that we are on our side here, like this. And I know that my fixed point is, this is going to be 1/3, 0. And I'm drawing this bigger than normal because 1/3 is, 1/3 is very small. So from here to here is 1/3 units. So you have to go 1/3 the other way, and that's going to be your directrix. So your directrix is the line x equals -1/3. Questions? Okay, back side. What is the equation of the parabola with the vertex at the origin and the directrix is the line x equals -5/2? So the vertex is at the origin, and we have the directrix. This is x equals -2.5. -1, -2, and there's -2.5. Okay, so if this is the case, then this has to be drawn like that. So how many units is P away from the vertex? 2.5 units. So if I wanted to know where the focus point is, it's 2.5 comma 0. They want the equation. What is the equation of this parabola? So is this going to be a y squared equals 4px? Or is it going to be a y squared equals negative 4px? Which one?
Just the 4.
This one. Because these branches are pointing to the positive side. All you need to do is put p is 2.5. And what's 4 times 2.5? What's 4 times 2.5?
10.
10. So the equation is going to be y squared equals 10x. And you could divide by 10 and get x is equal to 1/10 y squared. For B, this one, you are given this equation. The parabola has an equation x equals negative 4y squared. So what I would do is I would first reverse it. And then I would get rid of this negative 4. So if you multiply this by negative 1/4, so now I need to force the factorization of a 4 out of here. And it's going to be a negative 4. So what would this be? 1/16. Because negative 4 times 1/16 is negative 1/4. So they want to know now, where is the vertex, the focus, and the directrix? So this is a parabola on its side, pointing to the negative side, like that. My vertex is going to be the origin. My directrix, and I'm going to exaggerate it, it's going to be 1/16, it's the line x equals 1/16, 1/16. And my focus point is going to be negative 1/16, comma 0. So from here to here is 1/16, and from here to here is 1/16. Okay, and then the last type of problems that you're going to deal with are completing the square. These are where you have to complete the square and figure out where the vertex is going to be. The vertex is not necessarily always going to be the origin. And that's what you'll see here. Okay, so step 1, what you're going to have to do is complete the square here. I would slide, we did these in chapter 4. You're going to complete the square just on this side. So slide 8 over. You're going to take half of negative 4, which is negative 2, and square it. You're going to add 4 here and subtract 4 here. Factor this and add these two. You get 8 minus 4 is 4. Add 4, subtract 4. So this should be 4. This is a type. Should be 8 minus 4. So you have, now what I did here was I brought this 4 to the other side. Well, this is wrong. Something wrong there. So, let me start over. Y equals x squared minus 4x plus 8. Okay, so slide 8 over. Let's start over. Okay, half of this squared is 4. You're going to add 4 and subtract 4, right? So you get y equals x minus 2 squared. This is plus 4. Now, I know why it looked confusing, because you want to get rid of this. I'm going to bring this over. So you're going to subtract 4 here.
Plus 8 minus 4, which would be another 4.
No, 8 minus 4 is 4.
But didn't you already add that 1 over?
You slid 8 over, and then you take half of this and square it. You get 4. You're going to add 4 and subtract 4 because you're working on the same side, just like we did in chapter 4.
So what if I was a 4 to negative 4, just cancel out?
Well, no, you don't wanna cancel this out, cause you need this piece to factor this to be x minus 2 squared.
So when you 7 and a 4 over there.
Yeah, you have 4 here. 8 minus 4 is 4. This is that.
But you only added 4.
You added 4 and you took 4 away, so you added nothing to this problem. Okay, so this factors to be x minus 2 squared, this piece factors to be x minus 2 squared, and 8 minus 4 is 4. So now you want to get this 4 out of here, so you're going to subtract 4. You're going to have y minus 4 is equal to x minus 2 squared. Okay, now this is where it's tricky. Let's get the x squared on the left. Now, you have to pull out a 4 here. So, how are you going to write this where you have a 4 in front? Now, I know the vertex now is going to be 2, 4. But I need, in front right here, I need a 4 or a negative 4. It's going to be a positive 4 because I don't see anything negative going on here. And I'm going to make my p-value 1, 4. Because right now, in front of this y is a 1. So what two numbers multiply to give you 1 with a 4 involved in it? 4 times 1/4 is 1. We call this forcing the factorization of a 4. So now I know that my vertex is at 2, 4. I know that my parabola is going up because it's x squared. The x value is what is squared. So I have at 2, 4. Here's my vertex. I know this thing is going up like this because it's x squared. And I know that my fixed point is 1/4 from that vertex. So what is the name of this fixed point? What's this point here? It's going to be 2, 4 1/4. That's my fixed point right there. And where's my directrix? You're going to go 1/4 from that vertex, and this is going to be the line y equals 3 3/4. Because you have to go 1/4 of the way away from that vertex. You get this. And I have it all written here for you. So over 2, up 4 1/4, and this is going to be your directrix, y equals 3 3/4. Your p-value is 1/4. You're going to go 1/4 this way and 1/4 that way. You get this. Let's try one more. Okay, starting over. Alright, so now I want to know what's the vertex, the focus, the directrix, graph it, everything. So I know that this is x squared, so I'm going to complete the square. I want to slide 18 over. Just move it out of this, get it out of the way. Take half of this, which is 4, and square it. You're going to add 16 here, but you have to take it away there, because you want this to be nothing. So this factors to be x plus 4 squared, and this is, what's 18 minus 6? 16. 18 minus 16 is 2. Now I'm going to subtract, get this 2 out of here. And then I want my x squared on the left side. Now again, I need a 4 in front here, so I would have to put a 1/4 for my p-value to keep it balanced, because 4 times 1/4 is 1. So where is my center, or my vertex, I'm sorry? It's at -4 and 2, right there. and this is gonna be going up like this. My p-value is a quarter, I'm exaggerating it a little bit. So this is 1/4 unit this way. So if you added a quarter from 2, this would be -4, comma, 2 1/4. That's your fixed point. Your directrix is gonna be a quarter of the way away from it. So your directrix is gonna be the line y equals what? 1 3/4. You got it. And that's it. So, what do I want you to do for homework? We're gonna do the rest of this tomorrow. But for homework, I have this worksheet.